A warm welcome to all of you. In today's class, we are going to talk about the resonance. Resonance is the concept from the chapter sound of your physics syllabus. I know most of you find this concept of resonance to be very difficult. And on the top of that, question related to this concept is asked everywhere in the question paper in the form of MCQ, in the form of diagram based question, also answer in short and long answer. So concept of resonance becomes very important. And in school and in your coaching classes, most of the teachers don't cover this concept very well. Most of the junior teachers also have the problem with this concept. So I request all of you to watch this video completely with full attention and till the end. And at the end of this class, I am sure you are going to become a god of resonance. I will cover the concept of resonance in my 4 different short videos, and this will be video number 1 out of those 4 videos. So without wasting the time, we will start with this concept. Here I am Pravin Sonavane and you are watching India's most reliable and relevant educational channel where you get best in class study material and video lectures. Do check the links in the description box. Resonance is the phenomenon, and to understand this phenomenon we have to understand the 2 terms. Term number 1 is the natural vibrations and term number 2 is the forced vibration. First of all, we will observe this pendulum closely and minutely, and on the basis of our observations we will try to derive certain definitions which will bring us to our phenomenon of resonance. Okay, so have a look here carefully. This pendulum has a bob and a thread of a certain length. When I disturb this pendulum from its mean position, what do I observe? I observe the amplitude of the pendulum. Amplitude means distance covered by it from a mean position. This is mean position, and suppose if it is covering a distance of 10 centimeter from a mean position, then this distance covered of 10 centimeter is called the amplitude. Have a close look on the amplitude. I am disturbing this pendulum only once, so it has started vibrating, and when I see the amplitude of the vibration, with every vibration its amplitude is decreasing, still further decreasing, and vibrations are lesser and lesser in amplitude, and finally it will be in its mean position again and its rest position again. What kind of vibrations have we seen? So the vibrations which we have seen are called damped vibrations. The periodic vibrations of a body of a constant amplitude in an absence of external force, these vibrations are called natural vibrations. Natural vibrations are in the absence of the external force. सिर्फ एक ही बार वाइब्रेट करेंगे, फिर बॉडी will keep on vibrating with a constant amplitude without any external force. Then those vibrations are called natural vibrations. Sir, show us natural vibrations. I cannot show the natural vibrations because for showing natural vibrations I require a perfect vacuum. I require the absence of gravity. If I remove all these forces which are opposing the vibration of the pendulum, then only it will show natural vibrations. So try to understand the vibrations. If I want vibration of a constant amplitude, I will have to periodically apply a force at a regular interval. So this external force at a regular interval produces a vibration of a constant amplitude, and these vibrations are called force vibration. Every time in a damped vibration the amplitude will keep on decreasing. लेकिन अगर हम इस ऑब्जेक्ट को, इस बॉडी को वैक्यूम में लेकर जाएंगे या स्पेस में लेकर जाएंगे, एंड इफ वी अप्लाई अ फोर्स ओनली वंस, it will keep on vibrating continuously without any external force of a constant amplitude without decreasing in any amplitude, then those vibrations can be termed as the natural vibrations. और हमारे दुनिया में अगर हमको चाहिए vibrations or of equal amplitude, then those vibration has to be a forced vibration. फोर्स वाइब्रेशन में हम लोग क्या करते हैं, तो ये पीरियोडिकली फोर्स अप्लाई करते हैं. यू माइट हैव एक्सपीरियंस दिस. जब आप झूले में बैठकर झूलते हो तो उसका वाइब्रेशंस कंटिन्यूअस रखने के लिए एवरी टाइम यू कीप ऑन अप्लाइंग अ फोर्स, यू अप्लाई अ फोर्स पीरियोडिकली, तो उसका एम्पलीट्यूड भी डिक्रीज नहीं होता है और उसके वाइब्रेशंस आर लाइक नेचुरल वाइब्रेशंस. ओके, बट दिस फोर्स under the influence of the external periodic force are called forced vibration. तो हम लोगों ने तीन टाइप के वाइब्रेशंस पढ़े. नेचुरल वाइब्रेशंस. नेचुरल वाइब्रेशन इज अ मिथ. इट इज पॉसिबल ओनली इन द वैक्यूम, not in our world where we are surrounded by the atmosphere, where we are surrounded by air molecules, dust particles, etc. So all this opposes the vibration of the pendulum. और हमको क्या दिखाई देता है, तो डैम्ड वाइब्रेशन. इन अ डैम्ड वाइब्रेशन एम्पलीट्यूड कंटिन्यूअसली कीप्स ऑन डिक्रीजिंग एंड फाइनली द बॉब कम टू रेस्ट, कम टू मीन पोजिशन. But the vibration of a body of a constant amplitude in the absence of external force is called the natural vibration. And I repeat once again, natural vibrations are not possible in our world. It is only possible in the space or in a perfect vacuum without the gravitational force. So what we see in our world is the damped vibration, and the forced vibration is the vibration of a body of a constant magnitude under the influence of the external periodic force. So after learning these three kinds of vibrations, that is natural vibrations, damped vibrations and forced vibration, we are all set to learn the phenomenon of resonance. Have a look at this question and a diagram. In a diagram, you will see that there are two bobs, bob C and bob D. They are both attached to a wire. And what we are doing is, we are applying a force on the bob C only once. Only once. So it starts vibrating. And when bob C starts vibrating, you will see that this vibration has passed from bob C to bob D. So here comes a question number 1, कि what kind of vibrations are executed by bob C. So we have vibrated or we have applied a force on bob C only once. So the kind of vibrations it will execute is the free vibrations, and the energy of these vibrations from bob C is passed on to the bob D, and bob D also starts vibrating. Here comes question number 2, that is what kind of vibrations are executed by bob D. So bob D will execute forced vibration. Understand the question. We have applied external force on bob C only once. So bob C starts moving. This kind of vibrations are called natural vibrations. When bob C is moving, its energy is passed by this wire to which these bobs are attached to bob D. Energy passes from bob C to bob D, and bob D also starts moving. Now the motion of the bob D or the vibrations of the bob D is called the forced vibration. Now listen carefully, we are about to make one change in the given arrangement, and this change is, we are going to make the strings of both the bobs C and D equal in length. when the strings of both the bobs C and D are equal in length. Now bob C is moving with the natural vibrations and bob D is moving with the forced vibration, and if the frequency of the natural vibrations of bob C is equal to the frequency of externally applied periodic force in bob D, if both the frequencies are equal, then we are going to experience a phenomenon of resonance. What is resonance? That is, both the bobs will start vibrating with maximum amplitude. Question number 3 is, what if the length of the string of pendulum C and pendulum D are made equal? What change you will observe in the oscillations? So both the bobs will start oscillating with the maximum amplitude. Keyword is maximum amplitude. Question number 4, what is the name of the phenomenon when the lengths of the strings of pendulum C and pendulum D are made equal? This phenomenon is called the resonance. Now, let us try to answer 3 very important questions. What is the resonance? What are the conditions required for the resonance? And what happens at the resonance? The resonance is the natural phenomenon which occurs when the frequency of the externally applied periodic force, I repeat, when the frequency of the externally applied periodic force is equal to the natural frequency of a body, then body starts vibrating with the maximum amplitude, with the greatest amplitude, and this phenomenon is exactly called the resonance. What is the condition required for this resonance to occur? So condition we already have covered in the definition. Resonance occur only when the frequency of the externally applied periodic force is equal to the natural frequency of the body. This is the one condition which is required for the resonance to occur. What happens at the resonance? At the resonance, body starts vibrating, and this vibration has maximum amplitude. Now that we have understood the phenomenon of resonance, let us try to understand the equation for the frequency of the vibrating pendulum. Please try to understand that formula for the frequency of the vibrating pendulum is different from frequency of the vibrating strings, or for that matter frequency of the vibrating tuning fork or frequency of air column. Every time formula for the frequency is different. As of now we will concentrate on the frequency of the vibrating pendulum. The equation for the frequency of the vibrating pendulum is F is equal to 1 upon 2 pi into under root G by L. When we take a look at the formula of a frequency of a vibrating pendulum, we find that mass is not involved in this formula. Apart from constant, there are only two values, that is value of L and value of G. So mass is not involved. So we can say that if frequency of a vibrating pendulum does not depend upon the mass. That means if mass of a heavy body or mass of a lighter body is not important when we consider the frequency of the vibrating pendulum. And if we see the position of frequency and position of length of a string, that is L, in this formula, so one is in the numerator and other one is in the denominator. So we can definitely say that frequency of a vibrating pendulum is inversely proportional to the square root of the length of the string. That means if we increase the length of the string, the frequency of pendulum will definitely decrease, and this is the exam question. It can be asked in a form of a fill in the blank. And again I will like to draw your attention to the fact that frequency does not depend upon the mass of the bob. So whether a heavy mass or a lighter mass, that does not affect the frequency or a time period of the pendulum. Now have a look at this diagram based question. You might have seen this question in your pre-board examination also. In this diagram there are four bobs which are attached to a common wire or a common string, and we can see that ki bob A and bob C has a equal length, but bob B is shorter than A and C and bob D is longer. Bob A is set into vibrations, and we know that if bob A is set into vibrations, it will vibrate with its natural frequency. Here comes question number 1. The type of vibrations seen in pendulum B and pendulum D. So definitely pendulum B and pendulum D shows, yes, forced vibration. A is vibrated by us, so it will be vibrating with its natural frequency, and vibration is the natural vibrations. And bob B and D, which is not equal in length, will show the forced vibration. Pendulum A, when disturbed once by us, will vibrate with its natural frequency. And remember, bob B and bob D, or pendulum B and pendulum D, which are not of equal length as of pendulum A, will start vibrating with the forced vibration. So answer is the forced vibration. Here comes the second question, the reason for this kind of vibration in pendulum B and D. So pendulum B and D, we already have discussed that they shows a forced vibration. This vibration is shown because when pendulum A is vibrating with its natural frequency, the energy is passed from this pendulum to the other pendulum, that is from pendulum A to pendulum B and pendulum D. Here comes next question, question number 3. What is observed in pendulum C? So pendulum C has a length equal to the length of pendulum A. So this pendulum vibrates with the maximum amplitude. So oscillation of this pendulum C is with the maximum amplitude. Here comes the question number 4. The reason for the types of vibrations shown by pendulum A and pendulum C. The reason is that the frequency of the natural vibrations by pendulum A is equal to the frequency of externally applied periodic force in a pendulum C. Last question, question number 5. Name and explain the phenomenon. The phenomenon is called the resonance. And how do you explain resonance? Resonance is a phenomenon which occurs when frequency of natural vibrations is equal to the frequency of externally applied periodic force. Now here comes two additional questions which requires high order thinking skills. You can pause the video and you can write answer in your notebook. Once you are ready with your answer, you can replay the video. Now the next question is, what will be the change in the observation if pendulum A is replaced with the heavy bob? Means pendulum A or a lighter bob is replaced with the heavier bob. So what is the change? Answer is that there will be no change. Remember the formula for the frequency of the vibrating pendulum. F is equal to 1 upon 2 pi into under root G by L. Will the phenomenon of resonance occur if ball A is replaced by a heavier bob? So answer is yes, definitely it will occur as long as their lengths are equal, lengths of strings are equal. Again I will like to point out at the formula of the frequency, it does not involve the mass of the bob. So whether a lighter bob or a heavier bob, the phenomenon of resonance will definitely occur. Now have a look at the next question. This question is MCQ based question. You can see a diagram. There are four pendulums. Pendulum A, B, C and D. They are attached to a string at the top, and this string is a flexible string, and a pendulum C is set into the vibrations. Then they have given you four statements as a option, and they are saying that one out of this four statement is true and other three are false. What will happen when pendulum C is disturbed? When pendulum C is disturbed, it will show natural vibrations, while other three pendulums, that is pendulum A, pendulum B and pendulum D, will show forced vibrations. But have a look at the diagram. When we closely look at pendulum A and D have strings of equal length, so other pendulums will also vibrate, but these two pendulums A and C will vibrate with the maximum amplitude. When you go through all four options, you see that correct option is option B. Now read this question carefully and tell me what will happen when this bob is made up of ice. So if bob is made up of ice and if ice start melting, the mass of the ice will keep on decreasing. So if mass is decreasing, so they are asking us what will be change in the frequency, and we know that ki formula of frequency does not involve mass of the bob. So there will be no change in the time period or no change in the frequency. Without any iota of doubt, I am confident, I am sure that you have understood this concept of resonance and simple pendulum clearly. Next time you are going to handle all your questions with a greater confidence, and whatever question may be related to this topic, you are going to write a correct answer. Please don't forget to watch my next video, which will be based on vibrating air columns and the phenomenon of resonance. This video will also be very important. Like this video and share with your friends. Also subscribe to my channel and hit that notification button, because when I upload my next video, you will get the notification of that. So see you all in my next video. Till then, bye.